In this video, we will be talking about the acid chloride formation mechanism. The acid chloride formation involves a carboxylic acid and thionyl chloride reacting to produce an acid chloride, hydrogen chloride gas, and sulfur dioxide gas. Before beginning the reaction, it is important to identify the nucleophile, which is the chemical species that donates an electron pair in order to form a chemical bond. In this reaction, the nucleophile is actually the carboxylic acid oxygen. This is because in thionyl chloride, oxygen and chlorine are more electronegative than sulfur. If you remember, electronegativity increases across a period and decreases down a group on the periodic table. As a result, chlorine and oxygen will be pulling electrons away and sulfur will have a partial positive charge. There are 5 main steps in this mechanism. The first step is a nucleophilic attack, which is followed by resonance. The second step is the leaving group departure. The third step is another nucleophilic attack. The fourth step is the leaving group departure. Finally, the last step is deprotonation. In the first step, the nucleophile, the carboxylic acid oxygen, attacks the lone pair on the sulfur in thionyl chloride. As a result, a tetrahedral intermediate forms and the double bond on the oxygen on thionyl chloride is reformed as another lone pair. Now resonance occurs. Another form of the tetrahedral intermediate that exists is when the electrons move between the oxygen with the positive charge and the oxygen attached to the hydrogen on the bottom. As a result, the oxygen on the bottom can have a positive charge and the oxygen attached to the carbon can be neutral. In the second step, chlorine is kicked off because it is a good leaving group and more stable on its own. Chlorine is a weak, stable conjugate base of the strong acid hydrogen chloride, and it is okay being on its own. After the chlorine leaves, the oxygen forms a double bond. Because chlorine leaves and it is a gas, it cannot be reformed or reversed. As a result, the arrow is only in one direction. In the third step, the chlorine anion acts as a nucleophile and attacks the carbonyl carbon, making the oxygen lose its double bond. This also gets rid of the unfavorable positive charge on oxygen. In the fourth step, oxygen forms a double bond with the carbon, which causes the substituent SO2Cl to be kicked off. At the same time, the chlorine is kicked off of SO2Cl. This forms chlorine and sulfur dioxide gas. So the arrow is pointed in one direction because it cannot be reversed. In the last step, the chlorine that is kicked off then deprotonates the hydrogen on the double bonded OH to form the final products, hydrogen chloride gas and an acid chloride. Here I have the full mechanism written out so you can see the big picture of the full reaction that is occurring in an acid chloride formation. I will be moving on, but you can pause the video here if you would like to look at it longer. As you may have noticed, there are 3 types of arrows that appear in this mechanism. Equilibrium arrows indicate that the chemical reaction is reversible. Resonance arrows indicate that the 2 species in the reaction are resonance structures of each other, so they only differ in the arrangement of their electrons. Finally, the one-headed forward arrow shows that an irreversible reaction is occurring. Finally, this reaction is considered to be entropy-driven because of the 2 gases that are formed, which are hydrogen chloride and sulfur dioxide. When a gas is formed from a solid, entropy increases. In an isolated system, an increase in entropy therefore drives the reaction forward. So that is all for the acid chloride mechanism. There are many mechanisms in chemistry, but if you know how to approach the problems, then it will be easy. Some helpful tips to remember for all mechanism problems are: if protonation isn't possible, begin with the nucleophilic attack. Label your charges correctly. Make sure all your arrows are correct, and follow the main steps listed. Good luck!